Hi everyone. So today we're going to continue with numeric types, doing an even deeper dive. And you might ask yourself, man, how many times is he going to be diving to these variables and stuff? And my answer is this. At the end of the day, you're going to have better understanding than average programmer, which puts you in a better position. All right, so we are here to establish a solid base. So let's get to it. I'm going to open up Visual Studio Code. It's going to go to open folder. So let's say numeric types 2. Let's create a folder. All right, let's select it. Don't save. So we're going to go to terminal, new terminal, .NET new console. I'm going to click on program and enable debugging. Yes. All right, so a little way back, I was talking about conversions, right? So let's touch this again now that we have a better understanding. So you have these buckets that are of a certain type, and those buckets have names, right? So every numeric type outside ulong can be represented as long. So if I have a int number that is equal to 5, then I have a long, I can say long number, I can set it equal to number, right? So I'm trying to contain something smaller in something bigger. So no problem there, right? When I want to go the other way around, for example, I say int number 2, and now I want to set it equal to long number. I have a problem because it tells me that I'm trying to put something bigger into something smaller. So in events of this, you have to do it explicitly. You have to say, I understand what I'm doing, and that's what I want, right? So this is implicit conversion, and this is explicit. You're going to see where this is going, and I'm going to show you the danger. Now let's look at floating points, right? Same idea, right? Floating points, right? The idea is that every floating point can be represented as double, right? So let's say you go float, and you're going to say float number equal 5.4, right? It doesn't like it, right? Because remember, you guys, I mentioned that there is something called suffixes, right? So suffixes are needed when you deal with floats. So to make this work, I will have to say this 4.0f, right? Now I create a double number, right? I can set that directly to float number, and it will like it. So that's an implicit conversion, because you can contain a float inside a double. If you want to go the other way around, so I go float number 2, and I want to set it equal to double number, watch what's going to happen, right? It's going to complain, telling me that I need explicit conversion. So here, you have to say float explicitly that you're converting. Explicit conversion. For integral numbers, converting them to float, there's no issue. So let's go int number, let's say, let's do another float number 3, right? And we're gonna set it equal to number 2, right? Our float number 2 already exists, so we go 3. So you see, you can contain an integer inside a float. So that would be an implicit conversion. But if you want to go the other way around, so you go, let's say int number 3 equals to float number 3. You see, it starts to complain that I need an explicit conversion. So what would we do here, right? Int. So this is floating points. This is integral to float. Vice versa. Needs explicit. And now we have every integral can be converted into a decimal. So I go decimal number equals number 3. No problem. Going the other way around, as you might think, we're gonna run into another issue, right? So equal decimal number complains again. That needs to be explicit, sorry. So how would we do it? We just put an int. I typically don't use explicit conversions because of the danger of it. I'll show you why. I show you why it's dangerous to use explicit conversion. So let's say we have this int number 5, right? And we're gonna set it to 1 0 0 0 0 0 0 0 1, right? Right? Nothing wrong with that, right? Now we're gonna create a float f equals number 5, right? So we have here implicit conversion, right? Right? So now let's write console write line number 5 equals to f. So what do you think is going to happen here? This is going to be the true or false, right? I mean, number 5, sorry. So we have an integer. We set the integer to float. So on the surface, they look like f and number 5 is going to be the same. So let's see if that's in fact the case. It tells me they're true, right? So this still holds true, right? Right? So let's do something. So let's do int number 6. Now we're going to set it to equal to f, right? Doesn't let me. Tells me I need explicit conversion, right? Right? So now, let's see this, right? Number 5, is it equal to number 6? Okay, so let's let me add space here. Let's run this again. So now, wow, look at this, right? What the heck is going on? You take a number, number 5, you set it to float, you compare number 5, sorry, here, and float, they're equal. You flip the float back to integer, setting it to number 6, so they should be equal, but they're not. This is because the magnitude is preserved, but precision is lost. So what is this console write line? What is this number 6 equal to, right? What's going on here? You see, if I wouldn't dive deep into this, how would you guys know this, right? So look what happened here, right? Where's that 1 at the end? It disappeared, right? So you see, there's a danger with doing explicit conversions. It's like, you know, this telephone game with children, right? Someone says something and they keep saying to one another, and at the end of the day, it looks completely different. That's something like this, right? So when you use explicit conversion, there's a danger there, and I have illustrated you what happens. Have you guys ever heard of C++ or some Something like this, right? C++, right? Very famous programming language, right? If you're a gamer, a lot of games are written in C++. A lot of engines. It's a very powerful programming language, right? But what does C++ means? What does this plus plus means, right? So let's create a variable called C, set it to 0, right? So when I do console write line and I say C++, I'm going to write a description so you know what I'm trying to do. So what does this plus plus means? Plus plus means add 1 to it. Add 1 to it. When plus plus happens after the variable name, it's add 1 to it after evaluations, right? So what's going to happen here? Like, so if this is set to 0, add 1 to it after evaluation, right? So this will get evaluated to 0. 1 will be added. And 1 will be displayed in the second statement. So let me just show you how this is. So you see, when I did C++, it still showed me as 0. Because first the evaluation took place, then the addition, right? So this becomes apparent afterwards when I check the value of C, it tells me, right? Similarly, let me copy and paste this again. If I say plus plus C, right? Let me change this plus plus C. This means add 1 to it before evaluation. So what do you think is going to happen? There's 1 already here as C. 1 gets added to whatever was there, so you get 2. 2 gets displayed, and then 2 gets displayed again. So let me show you. You see 0, 1. Then we get 2 right away, because the pluses are before C. And then we check C again, it's 2. Similarly, you can do the same thing for subtraction. So you can do minus minus C. I add parentheses for clarity. So let me show you. So subtract 1 from it before evaluation. Then we're going to display the C again, right? So let's run this. Okay, so you see that now C becomes 1, and then it persists as 1 when we look at it after that. With integrals also, when you have a division, you have to know that when you do divisions with integrals, there are no remainders, right? So int a equal to 5, int b equal to 2. So let's write console, right line, 5 divided by 2. What is that equal to? Right? Let's say you don't know, right? So the best way what you can do is just see for yourself what it does, right? So it gives you the floor of 5.2, right? Right? So that's what you get. You get the floor, right? Let me put just this A over B. One thing to keep in mind that if you divide by 0, you're gonna get an error. So let's do another one. In C equals 0, right? So let's do 5 divided by 0. And we say C here, right? Show errors. Oh, okay. C already has been used before. So that's the problem. Okay. So let's divide it by D. You see, you get a exception occurred. Division by 0 is not allowed. So that's a runtime error. It happens when you run the program. So let's continue. So you have to be careful when you deal with division by 0. I can just show you a little preview of how you can handle something like this, right? You type try and you're gonna hit tab. Wait, try. Okay, so let me show you this this trick, right? So type try, go to the second option and press enter. So this gives you a little snippet of the code. Code is written for you. This is a little preview just to get you guys excited, right? So it's broken into 2 components, right? Try something out, right? If there's a problem, do something else, right? So I'm trying to divide by 0, right? If it's fine, nothing will happen, right? But if there's a problem, so here you can catch different exceptions, right? So this one happens to be a division by 0, right? System exception. Let me see, system division by 0 exception, right? If you know the exception, you can just you can select it, right? If you don't know, then you can just leave it as system exception, zeroed exception, right? So here you can write to the user, right? Division by 0 is not allowed, right? So what this will do is prevent the program from crashing, right? So let's save it and let's run it, right? So you see, we didn't get a crash, but we got a message that says division by 0 is not allowed. So it's much more clean this way, right? So I'm gonna stop right here, but we're gonna continue this fun. You guys can see that this thing is taking shape, right? I mean, before I was talking about explicit conversions, okay, it's good, but here you see the dangers, right? Now you're starting to see if something misfires, right? You have a try and catch. You can do something, you know, with problems. So guys, keep watching, and believe me, we're getting there. We're getting to a special place. So thank you so much for watching. Please subscribe. All the best. Bye bye.